It's funny. You pick up something simple, like a water bottle, or maybe a Lego brick, and you never really think about the massive, totally invisible system that had to exist just to get it into your hands. Our whole world runs on these hidden rulebooks, and today, we're going to crack the code on the one that's behind almost every single piece of plastic you own.
So, where do we start? Well, believe it or not, this whole story kicks off with a game of pool. Yeah, I know, it sounds weird, but the link between a billiards table and pretty much all modern plastics, that's the secret key to unlocking this whole thing.
Okay, picture this. It's 1872. Billiard balls are made of ivory, which is super expensive and hard to get. So a prize is offered, $10,000, which was an absolute fortune back then, to whoever could find a replacement. And this one inventor, John Wesley Hyatt, he steps up to the plate. He invents this machine that can inject hot celluloid plastic into a mold. Now get this, he didn't even win the prize. But what he gave the world was way bigger. He created the first ever injection molding machine. I mean, this thing is basically the great-great-grandfather of all the machines that make our plastic world go round today.
So Hyatt's invention, it completely changed the game. But when you have a global revolution like that, you need a rule book, a universal language everyone can speak. And that brings us to this one, kind of random-sounding number that runs the whole show for plastic-making machines. Code 8477.
Think about it. Every single thing that gets shipped from one country to another needs a code. It's all part of this giant system called the Harmonized Tariff Schedule, or HTS. It's basically like the Dewey Decimal System for everything. And heading 8477, that's the specific shelf in the library for machinery for working rubber or plastics. So if you're going to build a factory making, plastic toys, the machines you'd import, they're almost definitely living under code 8477.
So how does a customs officer figure out if some new gadget belongs in the 8477 club? Well, it boils down to a super simple two-question test. First question, is it described better somewhere else? A great example is 3D printers. They used to be in this category, but they got so popular they now have their very own code. So if the answer is no, it doesn't fit anywhere else, then you ask question 2. Does it actually work rubber or plastics? And work just means it has to physically do something to the material. Shape it, bend it, form it, whatever. If it does that, bingo, it's an 8477.
Now, the stuff these machines work with, it basically comes in two main flavors. On one hand, you've got thermosets. Think of things like epoxy. You heat them up, they set into this super rigid, permanent shape, and that's it. You can't remelt them or reshape them. They're a one-and-done deal. On the other hand, you have thermoplastics. This is the stuff in Legos or water bottles. You can heat it, shape it, and then, here's the cool part, you can melt it down and do it all over again. So really, one is permanent and the other can be recycled.
All right, so what machines are we actually talking about here? Let's do a quick lightning round and meet the 8477 family and see the everyday stuff they're responsible for.
First up, you've got injection molding. This is the direct descendant of our friend John Hyatt's machine. It basically just blasts molten plastic into a super precise mold under crazy high pressure. That's how you get things like those perfect Lego bricks, your phone case, or even parts for a car's dashboard. Then you've got extruders. The idea here is really simple. It's like squeezing toothpaste out of a tube. A big screw just pushes melted plastic through a specific shape, a die, and out comes a long, continuous piece. Think pipes, window frames, that kind of stuff.
And blow molding, this is how you get a plastic bottle. It's wild. They take a little tube of hot plastic, put it in a mold, and then inflate it with air, just like a balloon. The plastic pushes out against the mold walls, and bam, you have a bottle. And finally, there's thermoforming. For this one, they take a flat sheet of plastic, heat it up till it's all soft and floppy, and then use a vacuum to suck it down over a mold. This is how they make all those disposable cups, food trays, and that clear plastic packaging that's impossible to open.
Okay, so the system seems pretty cut and dry, right? You've got these machines, they do these things, easy. Well, it's not always that simple. Things can get really tricky. Let's dive into the bizarre case of the 3D drawing pen to see just how much of a puzzle this can be.
So there's this thing called the 3Doodler. It's a pen you hold in your hand and it melts and pushes out plastic so you can literally draw in 3D right in the air. So what the heck is it? Is it a toy? Is it a 3D printer? A power tool? This exact question landed on the desks of customs officials, and they had to figure it out. And this just lays out their whole thought process. They looked at calling it a 3D printer, but nope, it's not controlled by a computer model. You draw with your hand. Okay, what about a handheld tool? Nah, a tool like a drill changes something that's already there.
This pen creates the object from scratch. It wasn't really a home appliance either. So, by process of elimination, what was left? Well, what's its main job? It takes plastic, heats it up, and forms it into something new. And that, my friends, makes it a machine for working plastic. It lands squarely in heading 8477.
I know. This can all sound like a bunch of bureaucrats just splitting hairs over numbers. But this system, this whole code thing, it is absolutely essential to how our modern world works. It is so much more than just a code.
So why does it matter? Well, this code is the foundation of global trade. First, it makes sure trade is fair. Everyone plays by the same rules and pays the correct taxes. Second, it gives governments really important data to see what's happening in the economy. Third, it's a common language that stops things from getting stuck at the border. And finally, and this is huge for innovation, how your new invention gets classified can change how much it costs and how easy it is to sell around the globe.
And don't think this is some old rule book that's just sitting on a shelf collecting dust. No way. As this quote points out, the whole system is constantly changing. New laws, new executive actions, they're always updating it. When a new technology like 3D printing comes along, the rules have to evolve with it. It's a living, breathing system that's always trying to keep up with human ingenuity.
So there you have it. From a contest to replace a billiard ball all the way to a super complex global code that runs our world, the story of plastic is really a story about all these hidden systems. And it really makes you think, doesn't it? What other invisible rulebooks are out there, quietly shaping every part of our lives?